Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Geometry makes up almost one-third of the test questions. Standard 8.G.3. Understand congruence and similarity. Describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates.
Hello and welcome. Here is what you need to know before we get to the examples.
Before watching this video, it's highly recommended to watch the previous video, Matching Parts of Congruent Figures. Here's the link to it. Example 1.
Rectangle ABCD is shown. Stella rotates ABCD 90 degrees counterclockwise around the origin. Then she translates the rectangle to the right k units to create rectangle WXYZ. One side of WXYZ lies on the y-axis. What is a possible value of k? Okay, now here let's see. We have a 90 degrees counterclockwise rotation. So I'm going counterclockwise this way to the left, 90 degrees. This will end up being here. Okay, so let's find the coordinates of these points. So A is 1, 4, B is 2, 4, so and C is 2, 1, and D is 1, 1. Now here's the rule for rotation counterclockwise. So whether it's clockwise or counterclockwise 90 degrees, X and Y changes positions. One of them, only one, changes the sign. Now since here we are going to the left, so Y going to the left, Y going to the left, it changes its sign. So once you have this rule in place, now it's easy to see A prime is minus 4 because Y changes sign, minus 4, 1, minus 4, 2, minus 1, 2, minus 1, 1. So you have it. Here's your translated, rotated rectangle. Now the question here, they want one of these sides, this one or this one, to be on the y-axis. So if I move this one position to the right, this gets to be on, it ends up being on the line y-axis. If I go 1, 2, 3, 4, this will end up being here. So two possible answers, k is equal to 1 or k is equal to 4.
Example 2.
Now reminder, every time you see this picture, pause the video, and you may pause the video, solve the problem, and come back and check your answer. Here we have two triangles, EFG and E prime, F prime, G prime, and the coordinates are given. And the question is, which transformation can map this to this? Obviously, you can't just guess it like that. So you need to draw these points. Let's draw the triangles. Here's the first one, EFG. Okay, and the second one is this one here. Now you look at here, it says a reflection across the x-axis, a reflection across the y-axis, 180 degrees rotation about the origin, 90 degrees clockwise rotation about the origin. So if you look at reflection across the x-axis, this is your x-axis. If you reflect this across the x-axis, this will be down here. So that's not a. Now I mean, you can look at this here and find you can really see that it's a clockwise rotation about the origin. But we're going to kind of do some more work to make sure that we're right. It's a clockwise rotation, and I will show you how we can be sure of that. But if I look at the reflection across the x-axis, no, it doesn't work, because this will end up being here, this. a reflection across the y-axis, it doesn't work because this point here is going to be on the same line here. Okay. 180 degrees rotation, no, it's not going to work either because this point here is going to be right here. So now you can do it in a different way. Place your points, E, F, and G, E prime, F prime, G prime here. Now, look at the, what you notice is this is a change of sign here. 5 minus 5, minus 6, 6. And the rule here to make rotation clockwise, you're going to the right, X changes its sign. Okay, so X, Y changes positions for sure, but only one of them changes sign. X is going to the right, we are rotation clockwise, and then X changes its sign. So it's obviously 90 degrees clockwise rotation.
Example 3.
Rectangle MNOP is shown. Rectangle MNOP is translated. So translation means you're sliding it 3 units down. What are the coordinates of P prime? A question like that, it's a gift, it's a piece of cake. You have to really not make a mistake with a question like that. So we are going down here 3 units, and I'm interested in the point P. So P, from here, you count. 1. Don't start from here. Don't say 1 here. No, when you move, 1, 2, 3. So your P prime is here. And which is here what? Minus 4, minus 2. That's it.
Example 4.
Triangle QRS is located on the coordinate plane where vertex Q is located at the point AB, any point AB. The triangle is reflected across the x-axis and then translated 2 units to the right to create triangle TUV. Create an expressions for the x coordinates of T. So T is the final image of Q. So you can't just guess it like that. You have to do some work here, drawing, get the coordinate. Let's place any Q, place it anywhere you want on the coordinate plane, anywhere you want. Now choose an easy position for you. Don't go like negative here or here. So I chose here this point. This is A, this is B. It so happened here that 6 and 7, but don't worry about that. So this is A and this is B. That's Q. First thing we did, reflect. Okay, we are reflecting across the x-axis. This here is going to go down to here. Let's draw it. That's Q prime. That's just the reflection. A did not change, okay? Only B changed. Now we are going to translate it 2 units to the right. So that's the T. That's the image of these 2 transformations. So where is this? What is the x-axis of T? Is right here. And this one happens to be A plus 2. And that's the expression they want you to write. Okay?
Example 5.
This one is really easy. A figure is shown. The figure is reflected across line L. Okay? Across this line here. Which figure is the result of this transformation? It's reflection. So some of these options are clearly wrong. This one does not work. This one more like you're rotating it. Okay, this one doesn't work. This one doesn't work. You have options between this and this. If you look at this here, basically this is exactly the same as this. It's as if you translated it. If you translate this to the right, you get this. But if you want to reflect means flipping it. If you flip this here, you get this figure here. So obviously, these 2 are not working. Where is my cursor? This one and this one are not working. Now this one is not working either. So you are left with only this option. Okay. All right, very simple.
Example 6.
Two triangles, JKL and MNO, are shown. Okay, yeah, these here are shown. Which transformation can be applied to triangle JKL to create MNO? And let's read the whole thing. A clockwise rotation of 180 degrees, a clockwise rotation 90 degrees about the origin, a reflection across the line y is equal to x, a reflection across the x-axis. These two, I need to remind you, is these two here, the clockwise rotation and the reflection across the y is equal to x. So okay, here are the rules for reflections across the y is equal to x. This is the line y is equal to x. Reflection across this line means xy goes to yx. Okay? And rotation 180 degrees, basically xy changes signs, minus x, minus y. So now if you look at which one I started to eliminate here. Clockwise rotation. Is it a clockwise rotation 90 degrees? If you do rotation 90 degrees, this is going to end up being here. So that's not an option for sure. Reflection across the x-axis. If you reflect this across the x-axis, it goes down here. So that's also not a possible answer. So you're now left with two options to choose from: clockwise rotation 180 degrees, reflection across the line y is equal to x. If you take this point here, is minus 2, 4. Minus 2, 4. Is 4 minus 2 here? No. So for sure it's not a reflection across the y-axis. So the answer is a clockwise rotation. And if you look at that, see, this is minus 2, 4, 2 minus 4. Minus 4, 1, 4 minus 1. See, they're changing this. 4 minus 1. Okay, rotation. Yes. So now if you take the last one is, where is my cursor here? Minus 5, 3. 5 minus 3. Okay? So this is a clockwise rotation 180 degrees about the origin.
Example 7.
Triangle ABC has vertices 0, 1, 2, 5, 6, 3. A prime, B prime, C prime is created by reflecting triangle ABC over the y-axis. What is the x-coordinates of vertex C prime? This is really easy, so it's a level 1 actually. It's not level x, it's level 1. So let's see. Again, you have to do some drawing here. Let's draw this point. So I'm interested, this is a triangle ABC, so A is 0, 1, 0, 1, B is 2, 5, 2, 5, C is 6, 3. Now, A prime, B prime, C prime is created by reflecting triangle ABC over the y-axis. So now we are going to reflect this across the y-axis. So it's going to be here. Okay? See, A will be on the same place, B prime will be here, and C prime will be here. So, okay, here's a reflected triangle. So what is the x-coordinate of C prime? Once you get to this point, what is the x-coordinate of C prime? Minus 6, 3. 6, 3, minus 6, 3.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.